we're here for the science final. We're going to get the kinetic energy of this hill here and see if it's the same as the potential energy at the top. So with this experiment, we were seeing if the gravity potential energy at the top of the hill was going to reach my kinetic energy when I reached the bottom of the hill. How do we get gravity potential energy? We do this by multiplying mass times gravity times height. My mass, 135 pounds, was equal to 61.235 kilograms. Multiply that by the speed of gravity, which is a constant. Then we multiply that by 21.29 meters, which was the height of the hill. You may be asking, how do I know the height of the hill? We got the height of the hill by doing lunges all the way up the hill. So I took 88 lunges, which is about 1 meter per lunge. And then how steep is the hill? Around 14 degrees of incline. So all of this gets us about to 12,789.2298 joules of gravity potential energy. That is how much energy that we should have at the top of the hill when we're not even moving. Now with the trial, we're looking at our kinetic energy here. And this is half mass times velocity squared. So how do I know my velocity? In this experiment, we put down the meter stick and we were seeing how fast I was able to go down it in the frames of the video. Each frame is about 0.0167 seconds. So however many frames in theory times that number should get me how fast I'm going. So we took that number and then made it into meters per second, which is how we have our velocity squared. So in this case, in the first trial, it took me 6 frames to get past the meter stick. So in that case, I would be going 9.98 meters per second. So that squared times the half of my weight equals, for the first trial, my kinetic energy is about 3,047.8 joules. The second trial, I was able to make it past the meter stick in 1 less frame. So for the second trial, my joules is 4,391.9 joules of kinetic energy. And for the last trial, I was able to make it at the same rate as the first trial, which was 6 frames. So that would be 3,047.8 joules. All this averages about 3,495 joules of kinetic energy. Now, Mrs. Ciardi, you may be thinking 3,495 joules is a far cry from 12,789 joules. It's about a fourth of the speed, or a fourth of the energy. And to that, I would say yes. However, I believe that this is correct. I believe this big difference can be accounted into 2 different things. One is the fact that we don't live in a scientifically perfect environment. So I'm not going to go down the hill with no resistance like it would be in a perfectly scientific world. And the second would be human error. There was so much room for human error in this experiment, it's ridiculous. Human error number 1 that could have occurred was the meters of the actual hill. Who knows whether or not those lunges I was taking was actually 1 meter. The second would be the degrees of the hill. It was more of an eyeballing and a rough estimate of how many degrees the hill was of incline. Error number 3 could have been me going down the hill. Who knows if I had a better wheels on my skateboard, or if I pushed a little bit faster, if I could have reached this number better. And the potential error number 4 was my measuring method of the meters per second. When looking at a different camera angle, I saw that it actually took me about 4 frames to make it past the meter stick. So who knows if I messed up my way of measuring the meter stick because of the angle of the camera. All that being said, this points to one thing, and that is that I need to go faster. So thank you for this scientific experiment. I hope you enjoyed. It was a fun semester. I'll see you next time. God bless.